Welcome to This Explainer. You know, for literally millennia, we humans have looked up at the night sky and just wondered about that glowing red dot. But today, we're not just looking anymore. We're actually unpacking the very real, very active race to create humanity's first permanent settlement on Mars. We are taking this ancient romance and turning it into mind-bending engineering. We're talking about what it actually takes to build a second home for our civilization. To start off, I want you to picture something with me. Picture a world completely untouched by human hands for billions of years. You're standing right there on the rust-colored dirt. You look up, and the sun looks just a little bit smaller, a little dimmer than it does here on Earth. Swirling dust rolls across this vast, completely silent desert that just stretches on forever, all under this beautiful, alien salmon-colored sky. It feels peaceful, right? Maybe even serene.
Well, don't let that serene visual fool you, because the physical reality hides a brutal truth. Surviving here means dealing with average temperatures that routinely plummet below minus 60 degrees Celsius. That is colder than the absolute harshest, darkest winters down in Antarctica. Add in towering volcanoes that completely dwarf Mount Everest, and you've got a frozen desert that's going to test the absolute limits of human endurance and our greatest engineering minds.
So, here is our mission flight plan for This Explainer. We're going to start with the Martian dream. Figure out why we're choosing Mars in the first place. Face those harsh realities head on. Map out building the first colony. Look at what it takes to actually survive and thrive. And finally, zoom out to humanity's interplanetary future.
All right, part one, the Martian dream. It's wild to think about how our view of this place has evolved. For centuries, Mars was just this mysterious, kind of ominous red light. Ancient civilizations, like the Romans, actually named it after their god of war because of that distinct blood-red color. But then, fast forward to the 17th century, telescopes change everything. Scientists map its motion and use it to conclusively prove the heliocentric model of our solar system. Then, in 1898, H.G. Wells turns it into the ultimate sci-fi destination with the War of the Worlds. That cultural obsession fuels the space race, gets us to the moon in '69, and then, boom, 1976, NASA's Viking landers actually touched down. They proved Mars wasn't just a fantasy in a storybook. It's a tangible, rocky, and incredibly complex world.
Moving on to part two. Out of everywhere we could go, why choose Mars? Well, looking across our entire vast solar system, Mars is honestly the most practical location we've got. And it boils down to biological compatibility. Check this out. A Martian day is 24 hours and 39 minutes. That's basically an Earth day. Our circadian rhythms could adapt to that without freaking out. Plus, it has a similar seasonal tilt, meaning it gets spring, summer, fall, and winter. And the gravity, it's only about 38% of Earth's, sure, but that partial gravity is vastly superior to the near-weightless environment of a space station. Zero gravity destroys human bone density and muscle mass over time. Mars actually gives us enough gravity to potentially thrive for the long haul.
But here is the absolute game changer, the literal lifeblood of a colony: subsurface ice. After decades of sending rovers to map ancient dried-up riverbeds, scientists confirmed it. There are vast amounts of frozen waters stored at the poles and trapped right beneath the Martian dirt. And make no mistake, up there, water is going to be infinitely more valuable than gold. It gives us sustenance, obviously, but it also gives us incredible chemical utility.
Which brings us to part three, the harsh realities.
Look, before we go packing our bags, we have to admit something. Mars is actively trying to eliminate us. These are everyday lethal challenges. The atmosphere, it's incredibly thin and almost entirely carbon dioxide. If you stepped outside unprotected, the low pressure would be instantly fatal. On top of that, Mars lost its global magnetic field billions of years ago. Zero natural protection from deadly cosmic radiation. Throw in the freezing temps we talked about, and these massive, abrasive global dust storms that can literally blot out the sun for months, and you start to see exactly why Mars has historically been known as a planetary graveyard for robotic missions.
So how do we beat those odds? Part 4. Building the first colony.
We need a really ingenious blueprint. We have to set up shop in flat, ice-rich regions using a concept called ISRU, In Situ Resource Utilization. It's an elegant, four-step process to solve a massive problem. Bringing return fuel from Earth is way too heavy and ridiculously expensive. So we live off the land. Step 1, dig up that subsurface ice. Step 2, purify the water. Step 3, separate the oxygen out so we can, breathe. And then the magic trick, step 4, combine carbon dioxide from the thin atmosphere with hydrogen from the water to actually manufacture methane and oxygen for rocket fuel. We literally have to build an interplanetary gas station before we can even think about coming home.
Okay, so we've got our ticket home. Now we need a place to stay. Because of that deadly cosmic radiation, we can't just throw up a log cabin and call it a day. The very first structures are probably going to be inflatable surface modules that arrive pre-assembled. Then, robots will bury them under a thick layer of local dirt or regolith to act as a radiation shield. Later on, we might build rigid structures using regolith concrete made right there on site. But the most sci-fi, fascinating concept? Building entire communities safely inside massive underground volcanic lava tubes. These are ancient, natural caves widened out by the low gravity, and they offer incredible, ready-made protection from radiation and sudden meteorite strikes.
Right alongside housing is the relentless daily reality of food. You cannot wait on a grocery delivery from Earth when it's millions of kilometers and several months away. Plus, Martian soil doesn't just lack organics, it's laced with toxic chemicals called perchlorates. So, settlers are going to rely entirely on controlled indoor systems. Think massive hydroponic and aeroponic setups to grow crops without traditional soil. Using perfectly dialed-in artificial lighting and highly recycled closed-loop water systems, the first Martian diets are going to be heavily reliant on hearty, calorie-dense staples. We're talking potatoes, beans, tomatoes, and wheat.
Part 5. Surviving and thriving.
Because beyond just breathing and eating, building a true civilization means establishing a self-sustaining society. And on the edge of the frontier, absolutely nothing can be wasted. Resources need a 100% closed-loop system. Every single drop of moisture, yes, even sweat, and every breath of air gets captured and recycled. For energy, we'll need a fail-proof power grid, probably vast solar arrays paired with compact nuclear reactors for when those global dust storms hit. Medically, there's a huge communication delay with Earth, so no real-time emergency room consults. It'll be heavily reliant on AI diagnostics and 3D printing local meds. But honestly, the ultimate bottleneck? Psychology. Mental resilience. Surviving the extreme claustrophobic isolation of being millions of kilometers away from everyone you've ever known is going to take rigorous social structuring, meaningful daily work, and a whole lot of designated privacy.
Finally, Part 6. Humanity's Interplanetary Future.
Fast forward a few decades. That fragile little outpost is going to leverage advanced manufacturing and scientific breakthroughs to evolve. Which begs a really fun thought experiment. Can Mars truly become Earth 2.0? Pop culture loves the idea of terraforming, thickening the atmosphere, raising temperatures, turning the planet green. But physics kind of bursts that bubble. The reality is that creating localized habitable zones, like massive domed cities or sprawling underground networks, is way more practical than trying to restore a whole planetary atmosphere that the solar winds stripped away billions of years ago. It'll still be Mars out there, but a Mars totally adapted for human life on the inside.
I want to leave you with a provocative thought straight from our source material today. Mars is not merely a destination,
It is a gateway. Just let that sink in. Once we actually solve the unprecedented engineering, medical, and psychological hurdles of surviving on the red planet, our limits basically disappear. Mars literally becomes humanity's launch pad. Because of its lower gravity, launching ships from the surface is incredibly easy. It becomes our gateway to mining the asteroid belt, exploring the moons of Jupiter, and taking our rightful place as a true interplanetary species. The blueprints are already being drawn up. The only question left is, will you be alive to see the first launch?